Here's the next question, number 34. The driving point input impedance seen from the source Vs of the circuit shown below in ohms is dash. Okay, so this is not a multiple choice question and we will have to try and work it out. So in the circuit given to us, let's take the point A as shown. Now the question talks about driving point input impedance. So the driving point input impedance, I'll call it dz, is defined as the ratio of the EMF of the source to the current of the source. So which means that dz can be written as Vs by Is. Now Vs is the source voltage, which means that here is our Is, current that is passing through this branch over here. So let's take the point A and try and write down the KCL. We'll apply the KCL at point A and we'll write down the current equation and see how it goes from there. So applying KCL at point A. Okay, let's see. Now, if we apply it at point A, we see that Is is through that branch there, Is plus. Now here we have a current source and the direction of current is upward, therefore it would be plus 4V1. Okay, minus. Now we are going to take a look at this branch and this branch here. So it is VA by 3 minus VA by the sum of the resistances in this branch. So that's 4 plus 2. VA by 4 plus 2 is equal to 0. Now this is our current equation for the entire circuit at that point, at that node A. So we now have Is plus 4V1 minus VA by 3 minus VA by 6 is equal to 0. Now let me simplify this even further. I'll put it down over here. Is plus 4V1 minus VA by 3 minus VA by 6 will give us VA by 2 is equal to 0. So here is our basic current equation of the circuit simplified. Next, let's look a little further at the circuit. Now V1 is the voltage across that resistance there. That's what's given in the circuit, V1. And here the current that is from this current source is 4 times V1. So if we were to calculate just that corresponding to what is given over here, we can say that let's look at just the resistance there. V1 is the voltage across that resistance and 2 is the value of the resistance and Is is the current passing through that resistance. So using just that portion we can write down one expression. So the expression is V1 is equal to 2 times Is. So we know that V is equal to IR. R is 2. I is Is. So this is one relation. V1 is equal to 2 Is. Now the next relation, let's look at, we need to eliminate VA over here. In this equation we have Is, we have V1 and we have VA. V1 we can write it in terms of 2 Is. Now we need to try and eliminate VA. So let's look at this circuit once again and try to write down an expression for VA in terms of Is. So what we can do is, let's look over here. So VA, just the voltages. Okay, we'll look at just the voltages. So we have VA is equal to Vs minus V1. If we were to look at just this portion over here. So that gives us our second equation, second relation. VA is equal to Vs minus V1. Now V1 is 2Is. So that gives us Va is equal to Vs minus 2Is. Let's call this 1, let's call this 2. So now we have two relations. We have Va and we have V1. So let's substitute both 1 and 2 into this equation here. Alright, I'll write this down here now. So the equation is Is plus 4V1 minus Va by 2 is equal to 0. Now we substitute Is plus 4 into V1 is 2Is minus Va is Vs minus 2Is divided by 2 is equal to 0. Let's simplify this even further. We get 2Is plus 8Is minus Vs plus 2Is is equal to 0. This is times 2. So we further get this as 2Is plus 16Is minus Vs plus 2Is is equal to 0. Now we have 20Is minus Vs is equal to 0. Now the question asks us to find out the driving point impedance Zd, and we saw that by definition Zd is Vs by Is. So using this relation we can write this as Vs by Is is equal to 20 by 1. If we take this to the other side and rearrange the terms a little bit, we'll get Vs by Is is equal to 20 ohms. This is our final answer. Right, it's not a multiple choice, so it's 20 ohm. I hope this has helped.